Hello, this is going over 21-day drawing covalent bond practice. Our goal is to draw 6 covalent bonds over today and tomorrow and write the formulas for those compounds. So, this first bit, sorry. There we are. Is showing the steps. So we went over these steps last week on Friday. They're in the video that's posted with Friday's lessons. I'm not reading through all these again, but if you are unfamiliar with these, go check out Friday's lesson. But I wanted them here so you can reference them as you are working on this. And then this is our condensed periodic table. So it has the valence electrons all on here. It's just like with the, I can show you. It's with this pink elements cut out. Because whenever I'm like, okay, find the valence electrons, I always tell you, first column, there's one. Second column, there's two. Skip the pink ones. So this is just like a condensed version of that with the pink ones skipped. And so that's what this is. Oh, and it also tells you the number of bonds in the different elements. Next is this. This is our review refresher. Did this during class, but if you're absent, I'm going to go through it now. So the goal of this is to circle highlight the drawing of the covalent bond that is correct. So there's 3 drawings here, A, B, and C. One of them is right. 2 of them are wrong. And so we want to figure out which is which. So step 1 says add valence electrons for each atom. This will equal the total valence electrons available for bonding from the periodic table. So we're using the periodic table, or you could go 2 slides back and use that, or 1 slide back. This 1 slide back and use this chart. But so basically, in this, I have 2 H's, 1 H, 2 H, and 1 O, right? 2 H's, 1 O. So I want to find the total valence electrons that should be in 2 H's and 1 O. So I come here. H is in the first column, so it has 1 valence electron. O is in the 6th column, so it has 6 valence electrons. So my total valence electrons is going to be 1 plus 1 plus 6, which is 8. And this is how many there should be based on the periodic table. Step 2 says count the number of electrons in the covalent bond structure. Each bond equals 2 electrons and the lone pairs. So now I'm looking at this image, and I need to count how many electrons that are drawn. Each electron is 1, right? Each of the little dots is 1, and each pair represents 2. So if this helps you, put it on your pictures. If it doesn't, then ignore this. But you can add in electrons if you want to think about it. Okay, this line means there are 2 electrons there. And this line means there are 2 electrons there. And you can do it with all of them. You're like, this line up here means there's 2. This line down here means there's 2. Okay, if that is helpful for you, then do it. If it's not, just don't do it. I'm going to undo those ones just so. But I want them here. I like them, so I'm going to leave them. Anyways, so the total valence electrons shown is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total valence electron shown is 10. Next step, again, our goal here is to find the drawing that's correct. So next step is to compare. Are the correct total valence electrons used in the covalent bond structure? So basically, this is saying number 1, our answer to part 1, needs to match the answer to 2. So I should have 8 drawn, but I have 10 drawn. So I know right now this is incorrect. And if I wanted, I could X this out already. I know this is wrong. Okay. But I'm going to finish it just so you know what the next steps are. So then the next thing is the left hydrogen. So step 4. Check the octet rule. Do all atoms have 8 or hydrogen have a duet 2? Valence electrons. So if I am checking this, I need to first look at the left hydrogen. So it wants to have 2, and I need to see, does it have 2? So I'm going to use a different color just so those don't blend. So I am circling H in any of the electrons attached to it. So notice there are 2 electrons attached to that left hydrogen. Okay, that checks out. That hydrogen has a duet, so it's like, okay, I'm cool, this is good. Next, let me write that back in there, is I'm going to check the middle hydrogen. So this middle one, notice anywhere there's a bond, those electrons are being shared. So they get applied to anything that it's touching. Did I already count these 2 over here with this one? Yes. But they're also being shared with the central H, so like those count as well. So then I need to count. I have 1, 2, 3, 4 that are surrounding this H. So my center hydrogen gets 4 electrons. And if you want to leave those circles, if you like drawing them and they're helping you, you don't need to do all the back. Your ending picture can have circles around it. I don't care. And then next is the oxygen. So if we look at this oxygen over here, all of these are surrounding this oxygen. So the oxygen has 8 valence electrons. So again, what are we actually checking here? We're checking the octet rule. So do all the atoms have 8 or hydrogen has 2? This hydrogen has 2. This one has 4. So this is not happy. This would be another reason that this picture is incorrect, is because the center hydrogen has 4. This oxygen has 8. So the oxygen is actually happy, and the left hydrogen is happy. But the fact that the center hydrogen has 4 means this is wrong. So as a whole, in the end, you need a big ol' X on this image. Like, this is incorrect. Okay, so then you'll do the same thing for 7B and 7C. And one of these will have an X, and then the last one will not have an X, and that will be the one that is correct. But you do need to fill in all of this information to make sure that you know how to get there. So that's that. This is what is new today. Again, so all this stuff, honestly, it should be a refresher, which you might be like freaking out at that point, but hopefully you're not. We have done all of this already. So this is what is our new little thing today, is how to write formulas. So the formulas are like the shorthand notation. So often I'll write like, okay, you have 1 carbon atom and 2 oxygen atoms. The formula is CO2. So it's like that short thing written with symbols and numbers to represent what we are using. And how we do this, one thing that matters is the order. So like in this one, it's CO2. Why isn't it O2C? Like, why did the C come first? And so how we do that is it generally is left to right on the periodic table, except for hydrogen. So hydrogen is always the weird one, but it's generally left to right. So in that case, CO2, C is first because it's here versus O. So C is on the left side. You would like hit C first and then you hit O. So carbon is before oxygen. So it's left to right. And then the other little exception is hydrogen. So hydrogen sneaks in between column 5 and column 6, or the elements with 5 valence electrons and the elements with 6 valence electrons. So let me show you an example. It's usually just easier. We have H2O here. Actually, no, I'll show you this example. We have 1 carbon atom and 4 hydrogen atoms. So it's CH4. This is what the formula is. But if we look on the periodic table, H is over here, all the way on the left. So you would think, oh, I would list H first, but you don't, because H doesn't come until after this column here with the N. It goes in between N and O. So that's why this is C and then H4. There's plenty of examples. Oh, and then the other thing is the subscripts. So subscripts are the little numbers. So this is like F2. That little 2 is a subscript. That is the name of that. And basically, if I have words here, but it's easier, I think, to just look at it. So if you have 2 hydrogen atoms, you do H and then a little 2. So the 2 is representing how many of those you have. And then if there's just 1, so this is 1 oxygen atom, there's no number that you have to write. And this is a little familiar from ionic, but that's that. So next is the first example. I'm going to do this one, and then the rest, the 5 of them, because our goal is to draw 6 of them today and tomorrow. The last 5 you'll work on. I'm not doing those ones though. meaning you're doing them on your own. So hopefully you understand some things. Okay, so we have 1 carbon and we have 4 hydrogen. First bit is the atom type. The atom type is always nonmetals, always, because these are covalent bond. And covalent bonds are between nonmetals. The next bit is number of valence electrons. So I have 1 C and I have 4 H's. So I'm going to go back 3 slides, sorry. I need to find C. It's here, so there's 4 valence electrons, and then H, it's here, there's a 1 valence electron. So come back over here, and I have 1 C, so that's a 4, and then plus 4 H's, so there's 1 H, 2 H, 3 H, 4 H equals 8. So the number of valence electrons that I should have is 8. Full stop. That's it. Next is the covalent bond structure. So step number 2 says identify the central atom. So basically, how you do that is this. The center atom makes the most bonds. Okay. If all the bonds make the same number, place a single atom in the center. Atoms that only form 1 bond will be on the outside. If you need to pause and read this, do that. And then this says, be strategic. Attempt to make the structure symmetrical, meaning you have like one thing in the middle and then the things that surround it. It'll make more sense after we draw this. So C has 4 bonds. H has 1 bond. So C goes in the middle. It is our central atom because it has 4 bonds. You can kind of think of the bonds as like hands. So carbon can grab onto 4 different things. Hydrogen can only grab onto 1 thing. So you want the C in the middle because it can reach more things. So if we come over here, we have a C. There's just 1 of them. And then we have 4 H's. So I'm going to do 1 H, 2 H's, 3 H's, 4 H's. And now I'm going to just arrange them a little bit nicer so that they're kind of really surrounding it. And it's top, bottom, it's on the top and the bottom and the left and the right. And then what's next? Single bonds. Step number 3 is draw your single bonds. So I get a pencil. We'll go with this blue. This one's kind of cool. And we are connecting the atoms together. Okay, so these are the bonds. This is like what is making these stick together. So that's that. We added our single bonds. Next is adding our lone pairs. This gets a little tricky. So how do you know how many lone pairs you should add? That's the question that you should be asking yourself. There is 8 valence electrons that should be drawn because of up here. 8 valence electrons should be drawn. So I need to count how many do I actually have drawn. Because you have to have single bonds because these things are connected. So like you have to have them connected somehow. So you have to have those. And then we want to see. So how many does that mean? Like how many have I already drawn? So I'm going to add in these little electrons to just show us what these single bonds are representing. You do not need to do this part. So this is 1 and 2. That bond is 2 electrons. This bond is 2 electrons. So that's 3, 4. This bond is 2 electrons, so that's 5, 6. And this bond is 2 electrons, so that's 7, 8. So I have 8 electrons drawn, and I need 8 electrons drawn. So I do not add any electron pairs. If this number was an 8, pretend this number was 12. Okay? At this point, I have 8 drawn. I would add 4 more because I have 8 drawn and I need to get to 12. Okay, but that's not the case for us. But that would be why you would add them, is so that your number of valence electrons matches how many you have drawn. So I'm going to erase that. Next is checking the octet rule. So the octet rule is that we have 8 valence electrons surrounding all the elements except for hydrogen, which only wants 2. So We check this. This hydrogen has 2. This hydrogen has 2. This hydrogen has 2. And this hydrogen has 2. All those are happy. Now I'm going to erase all those circles because that was a mess. And then I'm checking this carbon. So any electrons that are touching it, I am counting, right? So this has 1, 2, 3, 4, 5, 6, 7, 8 surrounding it. It is happy because it has 8. So that is good. That is fine. This is finished. So I don't need to do anything else. And again, I'm going to erase these now at this point. You don't need those there. If you want them there, I don't care. You can leave them. That's fine. But this is a perfectly acceptable final. This is like the final answer. And then our formula. So this was our new thing. We have 1 carbon and we have 4 hydrogen. So remember, periodic table left to right, except for H, which goes after this column here, like between 15 and 16 on the periodic table, after the ends. So carbon is going to go first, and then H, and there's going to be a little 4 because there's 4 H's. Nothing after the C because there's just one of them. So C, H, and then the little 4, like so. And that's it. That's how you do it. Easy, right? No, so the next 5 are for you to do on your own. If you have questions, definitely ask me if you were absent. And like I said, I went into detail on 3 examples on Friday. So go watch that video if you are still super confused.